hard to actually get a full reaction to happen. And that's especially true when we have one of our things in excess. We've got more of one thing than the other. So therefore, it is common practice to add more than is necessary of one of our reactants to make sure that the other reactant is completely used up. Do you all remember that reaction that we did on Friday where I put the copper wire in the silver nitrate? Yeah? Okay, how much copper did we actually calculate that we would need to use up the amount of silver nitrate in this flask thing, graduated cylinder? Does anyone remember? No? It was a pretty small amount. It was like 0.56 centimeters or something. But we put way more in, right? And does anybody remember the reason why? Yeah, it had to do with the surface area, right? So we put way more in than we actually needed to react. So we kind of practiced this already. And what I want to show you, and I couldn't find tweezers, so I'm using scissors, but I'm just going to use my hand, is we actually did get a reaction here. So, that might be kind of hard to see. Can you guys see that there's like a little bit of a white kind of tip on this? So that's actually silver. So this copper, this did actually react with our silver nitrate to form silver. And you can have a closer up look if you'd like at this later. And there's also a little bit of silver in the bottom here. I'll just leave it up at the front and you can have a look at it on your way out if you want. But our copper was extremely in excess. We had an extreme excessive amount of copper to the amount of silver nitrate that we needed. So that was to make sure that we used up as much of the silver nitrate as we could to see that reaction occur. Okay. So in practice, we pretty much always will do that. So we'll always use an excess of one reactant. In a reaction. Usually it's the one that is cheaper or more easily recovered via separation techniques. The other reactant is completely used up. Is then known as the limiting reagent. And that is a super important concept. So the one that is completely used up, so our silver nitrate, in the case of the one that we did last Friday, that is called our limiting reagent. So limiting reagent that is the reactant that limits or determines the amount of a product in a chemical reaction. So in the example that I did, that oxygen was the limiting reagent, and it was determining how much magnesium oxide we were going to get. And then the excess reagent is the reactant that is not all used up in the chemical reaction. So this is not all found in the product. but it's left over after the chemical reaction takes place. And then we've got a nice visual here. Really? I thought lunch wasn't until noon. Weird. Okay. All right. So in this visual here, we are looking at two things. We're looking at hydrogen and chlorines. So these are our hydrogens, our H2s, and these are Cl2. So if we look at this reaction, what we're ending up with is HCl, these molecules, and H2. In this reaction, which of the two which of the two reactants, H2 or Cl2, is our limiting reagent? Cl2? Does everybody agree on that? Yep. So our limiting is Cl2. And that is all used up. It determines how much we can end up with. And then our excess? Yep. Awesome. And then let's just really quickly look at our actual formula for that. So we've got H2 plus Cl2 goes to HCl. Okay, notice that I'm not putting plus H2 over here. There's no plus H2. That H2 is left over from our reactant side. It is not a product. It wasn't made during the reaction. So if I balance this, if I balance this, I've got H2 plus Cl2 goes to 2 HCl. And then I've got 6 of these. Let's just call this moles. I've got 6 moles. I've got 4 moles. And then you guys can see that there's less of this one. It's our limiting. That makes sense, right? Okay. Does that visual make sense to everybody? Max, can you put your phone away? Okay, so we're going to do an example. So we are going to look at a question very similar to what I put on the board earlier, and we are going to figure out what our excess reagent is and how much of excess we have of it. So we've got 2 hydrogen plus oxygen gives 2 water, and we're going to figure out which reagent is in excess and by how much. So a simple way to figure out our excess reagent is to calculate the mass of one of the products in this case, our only product is water, but if you had 2 products, you could just pick one to use using each of the reactants. And then we are going to look at how many grams of that would be produced by each. So we're going to go how many grams of water will be produced based on, let's do hydrogen first. So based on hydrogen, how many grams of oxygen will be produced? So we know we have got 20 grams of hydrogen. And an H2 molecule has a molar mass of 2.0 grams per 1 mole. Our mole ratio is 2 to 2. So I've got 2 moles of water per every 2 moles of H2. And then I'm going to grams of water. So I'm going to go 18.0 grams of H2O per 1 mole of H2O. That's my molar mass. And I get 180.0 grams of water. Okay, so if hydrogen was reacting and there was an unlimited amount of oxygen, that is how much water we would get. But we only have a limited amount of water, of oxygen. We've got 100 grams. So now we're going to figure out how much water would be produced based on oxygen gas, and figure out, does hydrogen gas produce more or does oxygen gas produce more? And then because of that, which is our limiting? So I want you guys to do this, starting with 100 grams of O2. I want you to tell me how many grams of water would be produced. Do we need another minute? Okay, so did everybody get about 112 grams? No? Okay. So going through this, we've got 100 grams of oxygen. The molar mass of O2 is 32 grams per mole. So that's getting rid of our grams and into moles. There's a 2-to-1 ratio of water to oxygen. So now we've moved into moles of water. And then 18 grams of water per every mole of water. So if we calculate that out, we should get 112.5 grams. Okay, so which of these will be true in our actual reaction? Are we going to get 180 grams or 112 grams? 112, yep. So since there's only enough oxygen to make 112.5 grams of H2O, then that means that O2 sets the limit. So that sets the limit on the amount of water that can be formed. Therefore, oxygen, O2, is the limiting reagent. So O2 causes 112.5 grams to be produced, and H2 causes 180 grams to be produced. So because the amount of O2 can only produce this much water, it's the limiting one, because just the lower, yeah, because basically there's not enough oxygen to react with hydrogen to make that much. Okay, that also means that H2, that hydrogen, is the excess reagent. And we have been seeing these words a little bit in the past couple sections of chapter 7, when it would say something reacts with something and oxygen is in excess. So in this case, hydrogen is in excess. So all of our oxygen will react and we will have some hydrogen left over. In order to find how much H2 is in excess, we actually have to figure out the mass of the hydrogen that does react. Based on how much of the limiting reagent is used. So sometimes you might do a reaction and you might want to know how much hydrogen gas is left over. How much hydrogen gas am I collecting at the end of this? So I'm just going to show back to this photo here again, or back to this image. In this case, I had 1, 2, 3, 4, 5, 6 hydrogens and 1, 2, 3, 4 chlorines. And in the end, my hydrogen was in excess by 2. So I had 2 extra excess hydrogen molecules. So what we're doing is just figuring out what mass of hydrogen is left over in this reaction that we've just calculated. So how many grams of hydrogen are left over, assuming all O2 reacts with hydrogen. So what we're going to do is we're setting this up just like the questions that we've done in the past. So we have our equation is 2 hydrogens plus oxygen goes to 2 H2Os. And the information that we're given here is all of the oxygen is reacting, and the amount of oxygen was 100 grams. So 100 grams, and we want to know how many grams of hydrogen actually reacted. We know how many grams of hydrogen there was, but we want to know how much reacted. So we're going to go moles over to moles of H2 to grams. Okay, so I think we all know how to do this. 100 grams of O2, every 1 mole of O2 is, I'll move that up a little bit, 32 grams. And there's a 2-to-1 ratio of Yep, 2 moles H2 for every 1 mole of oxygen. And then our molar mass of hydrogen is 2 grams per 1 mole of H2. So what we end up with is 12.5 grams of H2 reacted. How many grams of hydrogen did we have to start? 20, awesome. So how many grams of hydrogen do we have left over? Yep. So 7.5 grams of hydrogen are left over. did not react. So that's the exact amount that was in excess. Okay, so we're gonna do a couple more examples, and then I'm gonna let you fly free. Okay, our next question, we have got 79.1 grams of zinc reacting with 1.05 liters of 2 molar hydrochloric acid to produce zinc chloride and hydrogen gas. And we want to know which reagent is in excess and by how much. Okay, so I want you guys to write out the balanced chemical reaction there. So take a minute, read through this, and write out the balanced chemical reaction or balanced chemical equation. Okay, so hopefully we got zinc, 2 hydrochloric acids, make zinc chloride and H2. So what we're going to do is randomly pick one of the products. To determine the mass of using each of the reactants. So we're doing the same thing that we did in the last question. In this question, in this reaction, there's 2 products. It does not matter which one you pick. I'm going to choose zinc chloride. Okay. So what we want to know is the number of grams of zinc chloride based on zinc, and then the number of grams of zinc chloride based on HCl. Okay, so this is a grams to grams in the end. So we're going grams, moles, moles, grams. This one is from that 7.3 concentration stuff where you're given a molarity and an amount going to moles, across the mole bridge to moles and to grams. So I'm going to give you guys a couple minutes. Try those. Oh, whoops. I'll give you another minute and then I'm going to put the answer up. Oh, it's so fast. Thank you.
So I created this as a teacher resource, and you can find it to Katrina.
Awesome. Okay, I'm going to put the answers up. So if you got through the calculations, did we get 165 grams based on zinc and 143 based on hydrofluoric acid? I know that was a lot of calculating to get through. Okay, so this is what we should have. I'll give you a second to copy that down if you didn't get through them all. Sorry. All right, which of these is my limiting reagent, you guys? HCl or Zn or zinc? Oh, sorry, we're still writing. Okay. Okay. It kind of gets in the way of the screen, hey? Okay. How much zinc chloride is going to be produced by this amount of product, or by this amount of reactant? 143 or 165? 143, great. So what does that make our limiting reagent? Good. Therefore, HCl is the limiting reagent. Because it produces a smaller amount of zinc chloride, and zinc is the excess reagent. If this was a struggle for you, this one, finding based on molarity of HCl, review the last thing we did, 7.3, and do some more questions from there, read through that, ask for help if you need it. But yeah, if that one was hard for you, that's from 7.3 molarity. Okay, so then the next step would be finding the grams of zinc left over. Grams of zinc left. So we've got, I'll just write the reaction down here again. Zinc 2HCl, zinc chloride, H2. And we're doing HCl is our limiting. So we're going 100, oh wait, whoops. Yeah, 1.05 liters of this. We need to go to moles, and then to moles of zinc, and then to grams of zinc. So to do that, we've got 1.05 liters of HCl, and we know that it has a concentration of 2 molar. So there's 2 moles in every 1 liter. So by doing that, we're eliminating liters, we're canceling out liters, and we're left with moles. And then we are doing our ratio, our mole bridge. So there's 2 to 1. So 2 moles of HCl for every 1 mole of zinc. And then we're going to go into grams. So there are 65.4 grams of zinc for every 1 mole of zinc. So what we're going to end up with is 68.7 grams of zinc was used in this reaction. We started with 79.1 grams. So 10.4 grams of zinc are left over. And then the last thing that might be asked of you is to determine the products from the limiting reagent, which is what we did above. So we did that above for zinc chloride. Do the same process using limiting for your other product, which in this case is H2.